You're out on a no-cool call. It's a scorcher of an afternoon. You walk up to that condensing unit and you hear it, that low, angry hum. You know the one I'm talking about. The sound of a motor trying its absolute hardest to start, but it just can't get going. It's a sound every tech knows, and it almost always points to one small but totally vital component.
So today, we're diving into the pros playbook for HVAC capacitors. In this explainer, we're going to move past just guessing and really lock in a disciplined, professional process for diagnosing and swapping out these critical parts.
So, here's our game plan. We're going to start with why these things are so important. Then we'll cover the absolutely critical safety stuff. After that, we'll get into identifying them, diagnosing the failure, and finally, doing a pro-level replacement. Let's get right into it.
First things first, let's really get a handle on why this little part is such a big deal. That humming motor we were just talking about, yeah, its entire life basically depends on this one component doing its job right.
So what does a capacitor actually do? Well, the best way to think of it is like a little electrical battery, or a reservoir for energy. It stores up a really powerful charge, and then, bam, it releases it in a targeted burst to give motors that extra kick they need to get spinning. After that, it helps keep the motor running efficiently. Without that initial jolt, the motor just sits there, hums, and cooks itself. Okay, we've now come to the single most important part of this whole explainer, safety. And let me be perfectly clear, what we're about to talk about isn't a suggestion, it's not a best practice, it is a non-negotiable rule for any professional working in this field. And here is exactly why. That energy reservoir we just talked about, well, it doesn't always empty itself out when you pull the disconnect. It could hang on to a high-voltage, potentially lethal charge for a long, long time. Just assuming it's safe because the power's off is one of the most dangerous mistakes you can possibly make. So, here's the deal. You have to follow this exact sequence every single time, no shortcuts. Number 1, disconnect all power and lock it out. Number 2, use a proper discharging tool like a 20,000 ohm resistor and hold it across the terminals. This bleeds off that charge nice and safely. And number 3, after a minute, you verify it's discharged by briefly shorting the terminals with a well-insulated screwdriver. You are not safe to touch that thing until you have done all 3 of these steps. All right, with safety locked down tight, we can confidently move on to identification. Let's become experts at knowing exactly what we're looking at when we open up that electrical panel. Out in the field, you're mostly going to run into 2 types. You've got your run capacitors. Think of these as the marathon runners. They're always in the circuit, helping the motor run smoothly, and they're usually housed in those metal cans. Then you have start capacitors. They're the sprinters. They give a quick, powerful kick just at startup, and then they're out of the circuit. You'll usually spot these in black plastic cases.
And then there's the one you're going to see all the time in residential AC units, the dual capacitor. All this is 2 run capacitors packed into one can to save some space. And the terminals couldn't be easier to read. C is for your common wire. Herm goes to the hermetically sealed compressor. And fan, well, that goes to the fan motor. It's super simple and really efficient.
Reading the label on these things is easy once you know what you're looking for. There are 2 critical numbers. The first is its capacitance, and that's measured in microfarads, or UF. So if you see a dual cap that says 35/5, that just means it's 35 microfarads for the compressor and 5 for the fan. The second number is the voltage rating, something like 370 VAC. Now remember, that's the maximum voltage it can handle, not what it's putting out. Okay, so we know what they are, we know how to handle them safely. Now for the fun part. Let's play detective. This is where we connect the symptoms you're seeing in the field to a final definitive verdict on that capacitor. You know, a failing capacitor can show itself in a few different ways. If it's shorted out inside, you're probably going to see the breaker tripping over and over. If it's open, that means the circuit's broken and the motor won't even try to start. That's when you get that classic hum. But the trickiest one, the sneakiest one, is drift. The capacitor is still technically working, but its microfarad value has dropped, which leads to weak performance and causes the motor to overheat. And this is a hugely important point. You cannot trust your eyes. A capacitor can look perfectly fine, no swelling, no oil leaks, nothing, and still be completely shot. A visual inspection is not a diagnosis. The only way to know for sure is to measure it. And here is the definitive test. Now look, a good multimeter with a capacitance setting is your best friend here, but understanding the actual physics is what makes you a pro. You can actually calculate the microfarads with this formula, 2650 times the amps you're reading divided by the volts across the capacitor. This is how you prove without a shadow of a doubt what that capacitor is actually doing while the system is running. So, what's the verdict? How do you know if it passed or failed? The industry standard is plus or minus 10% of its rating. So, if that 35 microfarad section is reading 30, it has failed. Period. And even if the system is kind of limping along, you have to replace it. A weak capacitor makes the motor work way harder, which creates excess heat that will absolutely cook the windings and lead to a much more expensive repair down the road. So you've done the safety checks, you identified the part, you've diagnosed the failure. Now it's time to execute that final step, a professional replacement that protects the customer's equipment and prevents you from getting a callback. If you get nothing else from this section, please burn these 2 golden rules into your brain. Rule number 1, the microfarad rating must be an exact match. No wiggle room, no exceptions. The wrong value will damage the motor. Rule number 2, the voltage rating can be the same as the old one or higher, but it can never be lower. A higher voltage rating just means the new capacitor is built a little tougher, which is totally fine. And here it is, your checklist for a perfect replacement every single time. 1. Power off and lock it out. 2. Safely discharge that old capacitor. 3. Take 2 seconds to label the wires before you pull them off. Trust me, it prevents mistakes. 4. Double-check the terminals on the new cap. 5. Mount it securely so it doesn't rattle around. And 6. Power it all back up and test the system's operation to confirm you nailed the repair. And this is why we follow a process like this. It's not just about swapping a part. When you do it right, when you do it professionally, you're protecting the customer's expensive equipment from damage. You're making sure their system is reliable, and you're showing them your value as a skilled pro. That's how you build trust. So I'll just leave you with this question to think about on your next call. Is your process for dealing with capacitors safe? Is it repeatable? And is it accurate? Every single time. By making this playbook your own, you can make sure the answer to that question is always yes.